We would like to find the Taylor series centered at x equals 0 for f of x equals natural log of 1 minus x. So we start with f of x equals natural log of 1 minus x, and we realize that if we take the derivative of this, we will have something similar to something we know the Taylor series for. So if we take the derivative, we get f prime of x equals 1 over 1 minus x times the derivative of 1 minus x, so negative 1. And we know the Taylor series for 1 over 1 minus x. So we know this whole thing is equal to negative 1 times the sum k goes from 0 to infinity of x to the k. So now how do we get back to our original function? We want to integrate. So we know we can integrate power series term by term. So that means that f of x is going to be negative 1 times the sum k goes from 0 to infinity of, now we just integrate the x to the k, so it's x to the k plus 1 divided by k plus 1. Now we want to find a Taylor series centered at x equals 0 for g of x equals the natural log of 1 plus 4x squared. But we know that f of x equaling natural log of 1 minus x has a Taylor series of the sum k goes from 0 to infinity of negative 1 times x to the k plus 1 over k plus 1. And we notice that g of x, being natural log of 1 plus 4x squared, is just f of x with negative 4x squared plugged in for the x. And so now we know that plugging negative 4x squared in for the x in the Taylor series we already have, we get the sum k goes from 0 to infinity, negative 4x squared to the k plus 1 over k plus 1. And now we want to simplify this just a little bit. So we get the sum k goes from 0 to infinity. We're going to have negative 1 to the k plus 1, but we also have that times negative 1. So we know that extra negative 1 here is going to shift the negative 1, so it's going to be negative 1 to the k now. And then we have 4, and that's to the k plus 1. And then we have x, and it's x squared to the k plus 1, so it's to the 2k plus 2, because that 2 distributes to the k plus 1. And that is still all over k plus 1. Now they're asking us to find the limit as x goes to 0 of the natural log of 1 plus 4x squared minus 4x squared over 4x to the 4th plus 5x to the 6th. So the first thing we do is check the form of this limit to see if we have to do anything interesting. And we get a natural log of 1 plus 0, which is natural log of 1, which is 0, minus 4x squared. And we put, as x goes to 0, that will also be 0. So we have a 0 on top. And on the bottom, we have a polynomial, 4x to the 4th plus 5x to the 6th. And when we plug 0 into that, we're also going to get 0. So this is a form 0 over 0. So we do need to do something interesting here. And so what we should do is use the Taylor series we just figured out for natural log of 1 plus 4x squared. All right, so remember that that was the sum k goes from 0 to infinity of negative 1 to the k, 4 to the k plus 1, x to the 2k plus 2, all over k plus 1. And so if we write out the first few terms, we're going to see that that is 4x squared minus 8x to the 4th plus 64 thirds x to the 6th plus ... and we could keep going. But hopefully that will be enough terms for us to figure out this limit. So the limit we want to know, the limit as x goes to 0 of natural log of 1 plus 4x squared minus 4x squared over 4x to the 4th plus 5x to the 6th is equal to the limit as x goes to 0 of 4x squared minus 8x to the 4th plus 64 thirds x to the 6th plus ... And do remember that this does keep going on forever. It's just not going to end up mattering to us. Minus 4x squared divided by 4x to the 4th plus 5x to the 6th. All right, so now we notice that the 4x squareds are going to cancel. And then when we look at the leading terms, we're going to have a negative 8x to the 4th and a 4x to the 4th. Now, some people say, how do we know that those are the leading terms? I thought we were supposed to look at the highest powers of x. So why aren't we looking at these x to the 6th? So let's look quickly at what this algebra actually is that tells us the x to the 4th term is what we want here. It has to do with the fact that the limit here is x goes to 0, not x goes to infinity. So what we're going to do is we are going to divide everything through by x to the 4th. So we have negative 8x to the 4th plus 64 thirds x to the 6th plus ... all over 4x to the 4th plus 5x to the 6th. We're going to multiply 3 by 1 over x to the 4th on both top and bottom, so we don't change anything. And that's going to give us the limit as x goes to 0 of negative 8 plus 64 thirds x squared plus ... over 4 plus 5x squared. And now you can see as x approaches 0 that the x squared terms are going to go to 0, as well as all the terms in the ... which all have x's in them. So we're going to be left with negative 8 over 4, which is negative 2. All right, the last part of this problem, we are looking at h of x, which equals x cubed, natural log of 1 plus 4x cubed. And we want to find the 77th derivative at 0 of this function. Now, we could take 77 derivatives, but that seems like a bad idea. So instead, we want to use Taylor series. So we know from the last problem that g of x equaling natural log of 1 plus 4x cubed has a Taylor series of the sum k goes from 0 to infinity of negative 1 to the k, 4 to the k plus 1, x to the 2k plus 2, all over k plus 1. So we notice that h of x is x cubed times g of x, so it will be x cubed times the sum, k goes from 0 to infinity, negative 1 to the k, 4 to the k plus 1, x to the 2k plus 2, all over k plus 1, and distributing through that x cubed, we'll get the sum k goes from 0 to infinity, negative 1 to the k, 4 to the k plus 1, x to the 2k plus 5, because we have 3 more x's, over k plus 1. And now, how are we going to find the 77th derivative of h at 0? Well, we know that the 77th derivative of h at 0 divided by 77 factorial is equal to the coefficient of x to the 77th in the Taylor series above. So we just need to figure out which term is the coefficient for x to the 77th. And notice that here x is raised to the 2k plus 5 power. So we're going to say, when is 2k plus 5 equal to 77? So that's when 2k equals 72 or k equals 36. So we want the coefficient to the 36th, to when k is 36. So to get that, we are going to look at, we're going to say h, 77th derivative of h at 0 divided by 77 factorial is equal to, I'm going to plug 36 in for k now on the coefficient. So negative 1 to the 36, 4 to the 37 over 37. And now I want to solve for the 77th derivative of h at 0. So I just move the 77 factorial to the other side. So h 77th derivative at 0 is negative 1 to the 36th, which is just 1, but we can write it, over 37, 4 to the 37th times 77 factorial. And that's it.